Mark conducts a science experiment and collects some data of the velocity of an object against time. He plots the information onto a graph and uses some software to fit a cubic function to his data. The model is given by v of t is equal to 0.0149 t cubed minus 0.4364 t squared plus 3.0262 t plus 0.8221. A. Use the function to estimate the velocity of the object at 8 seconds. B. Calculate the times at which the velocity of the object is 3 meters per second. And C. During the first 12 seconds, what was the maximum velocity of the object? Okay, to do this, first of all, I'm going to write out the function. And then jumping over to a GeoGebra outlook, because this is how we come up with the function. We've got this. So what he did, he plotted the points onto a GeoGebra axis like this. Okay, and then he used what's known as a polyfit degree 3, so for cubic model, and click, and there is my model. Notice that the function starts here and actually ends at the end of the data. You shouldn't go outside of the range of the data for the model. This was what it came up with. Also, a word of caution here, if you're going to do this yourself, make sure you use at least 4 decimal places for the cubic function, otherwise you're going to use a function which is not correct, which doesn't actually fit the data. If you just round off to like 2 decimal places, about 4 decimal places will give a reasonable fit for the data, and then you need to use 4 decimal places for the actual calculations. Okay, there's a screenshot of what I've done. So when t is 8, I need to do v of 8, which is 0.0149 times 8 cubed minus 0.4364 times 8 squared plus 3.0262 times 8 plus 0.8221. Using my GDC, so going to my GDC now, I'm going to a calculation mode and then typing in the function. You have to be very careful typing in exactly 0.0149 times 8 cubed minus 0.4364 times 8 squared plus 3.0262 times 8 plus 0.8221, and then press enter and you get 4.73. Now at this particular point I'm going to actually copy that as well, so highlight it and then do Command C. I'll explain why I did that later. Okay, there's a screenshot of what I've done. So it gives me 4.7309, and if I round that off I'm going to get 4.73 meters per second. On the graph I'll go to 8, just to show you up to the model and then across like this, and you'll read off here 4.73 meters per second. If you're doing this as a science experiment, this would be like complicated graph paper. Okay, so I now got to calculate the times at which the velocity of the object was 3 meters per second. So we require v of t is equal to 3, so we need to solve this equation, 0.0149 t cubed minus 0.4364 t squared plus 3.026 t plus 0.822 is equal 221 is equal to 3. So again, we're going to use the GDC to do this. So going to the GDC, okay, and now selecting a graphing mode and then doing Command V. Now be careful, hit the arrows here. You need to change all the 8s I put in to X, or you have to type the function in again. It's up to you. Okay, press enter. We haven't got a very good view window here, so I'm going to select a view window. So having drawn it a little bit before, Windows zoom, and I'm going to Windows settings. I'm going to put here -1. Remember, we use -1 so we can actually see the y-axis, and here I'm going to change this to 22. Press OK. Alright, so still not quite a reasonable view window, so we're going to go to Menu, Windows zoom again, and now do a zoom fit for that. Now I'm going to do Command G, and then I want to know when the velocity is equal to 3, so enter 3, and then all I've got to do is find the coordinates of that point, and that point using the GDC. So just going to move that label out the way, and then I'm going to do Menu, Analyze the graph, intersection number 4, to the left, to the right, Menu, Analyze the graph, intersection, to the left, to the right, Menu, Analyze the graph, intersection, to the left, to the right. Okay, so I've got the 3 points of intersection. These are the times when the velocity was equal to 3. There's 3 times during the experiment. Okay, there's a screenshot. Really, if this is an exam question, you should draw a sketch of the curve. Didn't write out the whole function here, but I did write down that v of t is equal to 3. Mark on the 3 intersection points 1, 2, and 3. Read down your graph. We're only interested in the times at 0.8122, 9.468, and 19.01. So times will be t is equal to 3 significant figures, 0.812 seconds, 9.47 seconds, and 19.0 seconds, rounding off correctly. Okay, for the final part, we want to know during the first 12 seconds what is the maximum velocity. So, using the GDC, right, we want the first 12 seconds. So really, to be able to see that first, if we do to Menu, Windows Zoom, and Windows Settings, and we just change the X scale to 12, we want to have a look at that part of the graph. So, there is a graph from 0 to 12, so the maximum is going to be this point here. So again, we just use the GDC, analyze the graph, maximum. Now it's going to ask me which curve, because I've got 2 graphs on the calculator at the moment. So just slide onto the blue one and select the blue one, and then go to the left of it and to the right of it, and we're going to get t is equal to 4.51. The maximum velocity is going to be 6.96. Okay, so if we draw our graph, we wouldn't draw it again, we just use the same graph we used for the last part. We'd mark on that maximum point, and we're actually only interested in the velocity this time because it says what was the maximum velocity. That's going to be the y coordinate one, which is 6.96. And finally, so the maximum velocity during the first 12 minutes the first 12 seconds is going to be 6.96 meters per second. Okay, it's quite a long video, but this shows you how to model a polynomial to a practical problem. Maybe an idea for a math studies project. I hope you have understood, and thank you very much for watching.